Hi, my name is Douglas, and I'll be, for the first podcast, I'm going to be doing a Boeing 737 Lean Six Sigma analysis. So, Boeing is one of the largest airplane companies in the world. It has sold more than 15,000 airplanes. It has competitors such as Airbus. You know, the Boeing 737 plane model managed to beat the upgraded A320 with the MAX version of the 737. So, moving on to the next slide. There's a couple causes worth investigating. You know, the software that determines one of the causes they were investigating that they wanted to look at the previous model of the 737 to figure out how it could beat the A320. I still honestly believe that these problems still exist in some capacity. Like, you know, they can deny it if they want, then they can. It really does not matter because I really don't think this is gone. You know, stuff that's in the past doesn't mean it stays in the past. So, okay, the first software that determines how a plane lands is falsely designed. So they have a history of high worker turnover. So it's not a surprise that programmers that are hired to write the software develop poor quality code, which results in bad software. There's poor documentation, going by prior history, they had an issue related to poor documentation where there aren't any writings on how to respond to unexpected situations where, the piloting system engages unexpectedly. There's a rush release date, the tight deadlines and rush releases aren't uncommon for most software being developed. The same is the case for the construction of the airplane itself. The managers for Boeing are pressuring the engineers to speed up the production process, and if there wasn't enough time for the Federal Aviation Administration to complete a review, the Federal Aviation Administration either signed off on the document themselves or delegated the review to Boeing. The people involved in the project for developing the airplane, they're kept out of the loop. The team in the project aren't given feedback on the progress on how they're doing. This could be done on purpose so they can match their progress, cut corners, make concessions, etc. There's delayed software updates for Boeing. There's a miscommunication on when software is available. This more specifically, no one really understood how the piloting system worked overall at the time. This is a sensor problem. There's a maintenance practice problem. There were pilot training problems. There's economic problems too. There were also pilot practice problems. So take whatever I say with a grain of salt. I looked this up. This was probably a very past article, but I feel like, again, still relevant today. And I don't feel like a factory tour for Boeing is going to make anyone change their mind on this topic. Like, I really don't think that's going to change anyone's mind. I mean, that's like saying, I don't know. You just have to go with your gut feeling sometimes. You really do. I'm sorry, Boeing. You kind of have to go. If people that make gut decisions, bad or wrong, right or wrong, they have to decide on their own, right? You can always make things look good and brushed up and polished up, right? I'm not saying I'm not dumb. I'm totally not an expert on this topic. I'm definitely not one, but I can tell you I feel like going on my gut, if you want to take it seriously or not. I mean, I have some reasoning, but I think there's something going on. So an enhancement was submitted to the FAA, so for certification on January 31st, only 4 days before the shutdown ended. This software update, submitted 4 months later than the initial estimate, will still require many more months to test, approve, and deploy. So this does get fixed later on, according to the article that I read. I wish I could still find it. So we're on to the measure stage for the Lean Six Sigma analysis. We're trying to investigate Again, it might have been fixed. I don't know. I really don't know. It's kind of hard to tell. Last I checked, the stocks seemed doing fine, but I know there were months when that airliner crashed, it really was flatlining. There, it definitely was bouncing rapidly up and down. I mean, it's not a great sign, right? It's a real thing. Like, it happened for a few months. You can't just deny this, right? It might have been less than a month, right? It might have been a couple weeks, but it's a big problem, right? It's kind of an issue. So I don't know. I know there was a serious conversation about this. That's about as far as I understand it. So Boeing decided to run some airplane tests to figure out how the software functioned. One of the things being measured was the airplane's tail movement. They did a system safety analysis on how the MCAS controlled the tail movements of the airplane. The tail movements were measured in degrees. AOA readings were done on the software controlling the piloting system for the airplane. Researchers would measure the difference in degrees between the AOA sensors that would do the readings for the software. An AOA is an angle of attack from which the chord of an airplane's wings meet the relative wind. The chord is a straight line from the leading edge to the trailing edge. Also, lead times were measured on how fast the computers that were running the software perform pre-programmed actions on the MCAS software in order to figure out if they can synthesize complex information in a fast amount of time to respond to emergency situations. Where, they're also going to be looking at total elapsed times for the AOA sensors responding to slight changes in the airplane wing's trajectory. So this seems like it's going in a pretty good direction. I got nothing more to say on this. So on the analysis stage, Boeing implemented some new software updates to their MCAS program. Here are the following updates. The flight control system will now compare inputs from both AOA sensors. If the sensors disagree by 5.5 degrees or more with the flaps retracted, the sensors won't move automatically. The MCAS can never command more stabilizer input than can be counteracted by the flight crew pulling back on the yoke. The AOA disagree condition will now be labeled as a standard feature. This is a useful functionality to have because it allows for flexibility in piloting. Sometimes the AOA sensors might be picking up something that they think is wind but really isn't wind. It's during these times that the pilot wings shouldn't move in response to it. The pilots will continue to always override the MCAS and manually control the airplane. Boeing realized that they need to set the right milestones for each period of time in their development cycle for the airplane, for each iteration of the airplane, to make sure that it can develop in a way that can beat the A320 airplane that the Airbus is using as their standard airplane. They've prioritized first-class documentation. First-class documentation is where the company prioritizes an easy-to-understand document following one principle. If it is not explained easily in simple terms, then the person does not understand it. So the pilots would therefore prioritize aviation. Going to the next slide. There's questions to ask during the first-class documentation process. How can one predict what information people need to know? What is too technical? What is enough information? Won't the details change as the system evolves? How will the documentation be maintained? Asking yourselves these questions will help iron out any other logistical issues that you might run into when designing an airplane. They might include discovering new edge cases. Edge cases are scenarios that you might encounter where an unexpected problem occurs when running your software or program. In this case, we're dealing with an airplane, so it's both the piloting software and the airplane that we need to consider for an unexpected situation. You discover novel ways to use the software. The pilots, through answering these questions, will invent new shortcuts to do airplane maneuvers that will help them utilize the MCAS software in a much faster amount of time, which will lead them to saving themselves from dangerous situations that can involve airplane crashes. You know, it is during these cases the MCAS software, which controls the AOA sensors, will not move faster, but rather the pilots themselves. This allows response times to resolve emergency situations to get reduced, while at the same time not putting any strain on the development team. And this concludes part 1 of the series.